Hello students, so hope you all are good. So we have already discussed about mirrors, spherical mirrors, concave mirrors and convex mirrors, their image formation at different object positions. So today we are going to talk about a slightly different concept related to spherical mirrors. First of all, we got to discuss about something known as sign convention. Obviously, signs are of two types, positive and negative. So here in optics, that is when you are writing the image distance, object distance, okay, so in those cases also we have to follow something known as the sign convention. Which convention do we follow? We follow the Cartesian convention. Cartesian convention, you must be knowing Cartesian convention. Even if you don't know the name, you know this, right? You know this: positive x, negative x, positive y, negative y. This side x is positive, this side x is negative, this side y is positive, and this side y is negative. This you must be knowing, right? So this is the same exact convention that we follow here. Okay. Now what you need to understand is, suppose this is the object. Here I have taken a this is a concave mirror. Here I have taken a concave mirror. Suppose this is the object and this is the the mirror. The distance of the object from the pole is called object distance. This you know, isn't it? This is object distance. So object distance is represented by u. In most of the cases, object distance is represented by u. Okay. Now you can see an image is formed here. So the distance of the pole from the image, this distance is called image distance. Okay, this is your image distance. Image distance, object distance. Okay. Now see. Now consider this pole to be the origin. This is the principal axis. So this is lying this side. Object distance is lying this side. Okay, towards the left of the origin. So you can see just like this from here. So if it is lying towards the left of the origin, that means object distance is negative and image distance is also negative if it is this side. Are you understanding? As it is lying this side, okay, towards the left side, we are following the Cartesian convention. Had it been a case where our image was formed somewhere here, suppose, just for an example, in this case u would be negative, obviously, object distance, because this is this side, and v in this case would be positive. Why positive? Because this is lying towards the right from the origin. So is it clear? So if we have a distance or a certain specific value or a certain specific length which is towards the left of the pole, so using the Cartesian convention we can say that that term will be negative, and if it is towards the right, that term will be positive. This topic, I mean this thing is clear to you all, hopefully. Now another thing is, you can see this is the height of the object, h. H is the height of the object, which is AB. You can see in the figure itself. Okay. Now it is towards the positive y-axis. You can see positive y-axis, positive, isn't it? So h, that is height of the object. Height of the object is positive. Whereas you can see the image is inverted. You can see, and it is, sorry, I'm showing a different, and it is lying downwards towards the negative y-axis. So height of the image h dash is equal to a dash b dash. Suppose if it is inverted, if it is upright, obviously it will be positive. If it is inverted, it will be a dash b dash in this case, and it is height of the image, and it is negative in this case. Are you understanding? It's very, very simple. You just have to follow the sign convention that we have been using till date. Graphically when you plot, isn't it? This side is positive, this side is positive, this side is positive y, this side is negative y. Are you understanding? So this is okay. Hopefully this is okay. Now if you have understood this, we will have to we'll write a few expressions related to this spherical mirrors, which are very very important from your examination point of view. One is called your mirror formula. Mirror formula is 1 by v plus 1 by u is equal to 1 by f. Okay, this is your mirror formula. And another one is magnification. So magnification, from the term itself it is clear. Magnification means if you have an object of 2 centimeter and if you have an image of 6, if you get an image of 6 centimeter, what do you see? You can see that the object has been you can see that the image has been magnified by 3 times, isn't it? So magnification, how do you know? You know how much is the height of the image and how much is the height of the object. So magnification is height of image divided by height of object. So we write it as h dash, height of image, and height of object is h. By how many times the object has been magnified when the image is formed. Okay, that is the meaning of magnification, and this is given by minus v by u. Now what is v? V is the image distance, u is the object distance, and f is the focal length. Now focal length, obviously we know. Suppose we have the focus here, so if it is lying this side, focal length is negative. If it is lying this side, f, then focal length is positive. This you know. But conventionally, when you use the mirror formula, you just write this, and after writing this, when we solve the problems, we'll see. And after writing this, we'll see which side is v, which side is u, and accordingly we'll write minus, plus, etc. Now, mirror formula, what is the significance of this mirror formula? The significance is that actually it is relevant to a lens when you people, some of your eyes may be defective in the class, some of the students. So when they go for a checkup, actually they give you lenses, okay, but more or less the story is same. They you know tell you to read out the alphabets and you know they give you some lenses in your eyes, and they ask you whether the alphabets are clear or not. So what they are trying to see is at which object distance is the image distinct to your eyes. Accordingly, he or she, that is the doctor, optical, you know, the doctor under consideration, will prepare a lens of a certain focal length. Actually, in that case, the formula is a bit different, but the idea remains the same. So after knowing, because they have the screen at a certain distance from from where you are allowed to sit, so that distance they know. And after knowing altering this u and v for different positions and different focal lengths they give you, they prepare the lenses of a particular focal length so that the image distance and object distance becomes perfectly feasible to you. Actually, in lenses this becomes minus, but that we'll discuss when we talk about lenses. So hope this discussion is clear. So this will be very very helpful, and these formulas are very very useful from my examination point of view. Just go through this, and in the next class I'll be solving some numerical problems related to it. Thank you so much.